Mini project has been done by Group B2-03 with Aisha Suhaidi, Natasha Alias, and Batrisha Faizal. This mini project is about determination of thermodynamic function of electrochemical cell of zinc and copper. Study of the relationship between chemical change and electrical energy is known as electrochemistry. Galvanic cell can generate electrical energy throughout the chemical process. On the other hand, chemical reaction is so-called electrolytic cell can be caused by electrical energy. This experiment is to determine some characteristic of the voltage cell. The relationship between change in free energy and the cell potential can be determined by the equation delta G equal to minus NFE, where delta G in joule, F is a Faraday constant, and is number of mole of electron or charge of ion involved, and E is in volt. The value of delta G can be obtained directly from the cell EMF measurement. The Gibbs-Helmholtz equation relationship may be used to calculate the other thermodynamic function, like the equation delta G equals to delta H minus T delta S, where delta H is enthalpy change, delta S is entropy change, and T is absolute temperature. Enthalpy describes change in heat in the system. If the system absorbs heat during a given process, this process is said to be endothermic, and the change in enthalpy is greater than zero. On the other hand, if the system releases heat, the process is called exothermic, and the enthalpy is less than zero. Gibbs free energy is the function derived from H and S. The change in free energy, delta G, is composite function that gives a measure of the spontaneity of the reaction. If delta G is less than zero, a reaction will occur spontaneously, and delta G is greater than zero, the reaction will not spontaneous. And if delta G is equal to zero, the system is at equilibrium. For the procedure part, firstly, the zinc nitrate solution was poured into the one of boiling tube, and the copper nitrate solution was poured into the other boiling tube. The beaker was filled with water. The system cell was neatly arranged by inserting the sub-bridge and the thermometer through the rubber cork. The electrode were cleaned with sandpaper, then zinc electrode and copper electrode were inserted to the boiling tube until the half of it were dipped into the zinc nitrate solution and copper nitrate solution respectively. After that, the beaker was heated by controllable heating system until the temperature of the solution reached the temperature, which were 30, 36, 42, 48, 54, and 6 degrees Celsius. The reading of each cell was recorded. Then delta H, delta S, and delta G were calculated, and the graph of minus delta G against absolute temperature T was plotted.
For the result, we start temperature from 30 until 60 Celsius. As you can see, the temperature is inversely proportional to the E cell. When temperature increase, E cell decrease. And for the second table, we get Gibbs free energy by using the equation delta G equal to negative NFE. Then we substitute in the equation, so we get Gibbs free energy as shown here. When absolute temperature increase, Gibbs free energy will decrease. Next, we plot the graph for Gibbs free energy versus absolute temperature. Then we get the linear graph with equation y equal to negative 0.0087x plus 4.3741. The graph shows Gibbs free energy inversely proportional to the absolute temperature. From the graph we plot, to get delta S and delta H, we compare with equation y equal to mx plus c. Delta S is gradient, which is negative 8.70 times 10 to the power of 2, and delta H is y-intercept, which is negative 4.37 times 10 to the power of 5 J per mole. Then for the delta G, we use equation delta G equal to delta H minus T delta S. We use standard room for the temperature, then just substitute in this equation, and we get the answer is negative 1.78 times 10 to the power of 5 J per mole. To calculate the theory Gibbs free energy for zinc and copper, we use equation Gibbs free energy equal to negative NFE. Just substitute and we get the final answer is negative 2.12 times to the power of 5 J per mole.
The graph plotted for zinc and copper cells shows that the reaction was exothermic, with a negative value indicating an exothermic state. The experimental delta G was calculated at 298 Kelvin, indicating spontaneous forward reaction at high temperatures. The theoretical delta G naught was negative 2.12 times 10 to the power of 5 joule per mole, resulting in a 16.04% percentage error. The experiment had several flaws, including submerged boiling tubes, water dilution, equipment resistance, loose rubber stopper, and not conducting the experiment in standard conditions, resulting in inaccuracies in the experimental reading voltage. These flaws contributed to the experimental results. This experiment is achieved as the thermodynamic functions in the cell system of zinc and copper determined from the electromotive force (EMF) measurements. The Gibbs free energy obtained for cell system zinc and copper is obeying the theoretical Gibbs free energy, as both the cell systems shows a negative value in delta G, which indicates that the reaction is spontaneous. Delta G is less than 0.